Good morning, Summer Academy on Monday, July 12th of 2021. How's everybody today?
Good.
Good. I see the thumbs up. I see good. I see chat. Great. All right, folks. So today what we're going to be doing is we are going to be reviewing the greatest common factor. So in case you forgot, it's okay. That's why I'm here to reinforce it, to kind of review and refresh your memory. However, today is going to be pretty straightforward. As you know, all you're responsible for today is an independent practice and an exit ticket, followed by completing 30 minutes of iReady, or 45 if you want to get done faster. Okay. Shout out to the people that actually did 2 hours or more of iReady, or that were close to that. Let's try to all aim for all of you to get your name on the scoreboard in the Google Classroom by Thursday at 3 p.m. Okay. So let's get this show on the road. I'm going to share my screen now, and I'm going to pull up what we have. Can everyone see my screen? Everyone can see this? All right, Branson Clark, you volunteered to read the learning target for Monday, July 12th of 2021, standard 6 NS4. Can you please read the learning target for me? Thanks, Haley, for the thumbs up. Branson, are you there? Daniel, good job, bud. Branson, are you able to read the learning target for us? You just have to unmute, bud, okay? If Branson's unable to, who would like to pick up for him? Daniel, you want to read it?
Wait, I'll do it.
Okay, go ahead.
Today's scholars will review we will review how to find the greatest common factor, GCF, and the least common factor, LCM, of two or more numbers. We will go over old common core questions and practice our skills of
Annotation.
And answer any questions.
Okay, so we're going to be annotating. We're going to be reviewing and refreshing how to find the greatest common factor and how to find the least common multiple. So important vocabulary words, greatest common factor. Thank you, Branson. We're going to pick somebody else, though, to be fair. Hey, Daniel, can you read number 1, greatest common factor for us? GCF, sir.
The greatest common factor shared between numbers. This factor that equals product in order from least to greatest.
Method.
Methods, rainbow. Method,
You're right. You got it.
method, factor tree, and list.
Awesome. Mr. Sanchez, can you read me number 2 where it says least common multiple, LCM, sir? Please.
Least common multiple. Least common multiple shares between numbers, skip count.
So let's look at what Daniel and Jason just read. So as Daniel just read, when you find the greatest common factor, you're listing the factors, which are 2 numbers that make up the product. So all the numbers that I can have 12 go in evenly, we have 1 and 12, 2 and 6, 3 and 4. All of the factors we say that make up 9. We got 1 times 9 and 3 times 3. In this example, you're going to circle what's common. What do they share? They share 3. So that is the greatest common factor, meaning the greatest number that I can divide both 12 and 9 by. Does that make sense? All right. When we list the least common multiple, we're going to list the multiples. We're going to skip count 2, 4, 6, 8, 10, 12, like that. And we're going to keep doing that for all of the numbers until we find a number that is common for either the 2 numbers we have to find the LCM or 3 with. So here we have 6 and 8. Clearly, if we count by 6, 12, right? 18, 24, because 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, and 4 times 6 is 24. We would do the same exact thing for 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. As we can see, they both share 24, so that is the least common multiple they have in common. Okay, the rainbow factor method, we've done that before. It's just another way to show you. And then I just listed more examples. Okay, so let's look at here, problem number 1. What is the greatest common factor of 42 and 84? So what should we annotate here? Somebody can come up and tell me, what is an important word that I should write under the A column? What are we doing? Look at the question.
Greatest common factor.
Good. Was that Daniel? That's you. Awesome. Of what numbers, sir?
42 and 84.
Good. So let's do that. Good, Daniel. Daniel, what do we have to find? What's the key here? What's the question asking for you to do?
To find the greatest common factor of 42 and 84.
Good. So Daniel, instead of me writing greatest common factor, I'm going to put GCF, okay? Just to make it easier. All right. Now, are we going to find the LCM or the GCF, Daniel? What's the method?
GCF.
And how do we find the GCF? Do we skip count or list the factors?
List the factors.
Great. So now we're going to put your thinking caps on. List the factors of 42 and 84. So let's look at the number 42. We're going to think of all the numbers that make up 42. Does 1 and 42 make 42?
Yes.
How about 2? How many times does 2 go into 42 evenly? About how many times? Do you have a calculator with you? Somebody help them. 2 times what? Who can help them out?
84.
Well, 2 times 84 wouldn't give me 42, though. That would give me a larger number. What's half? If you have $42 and you give me half, how much money do you have?
24.
Well, 24 or 21? What about 3? Does 3 go evenly? What's 42 divided by 3, folks? Anybody? Comes after 13. Oh, someone said 14 in the chat. Then we have 6 times what?
Times 7.
Good. So those are all the factors that make up 42. Now we're going to find the factors that make up 84. Yes, I am making you think a little bit, but I have a feeling that you can all do it because you're all capable. So now let's look at the factors of 84. I'm going to write 84 over here. I'm going to use red. Okay, 84 now. We know 1 times 84 is 84. We know that 2 times what? What's half of 84, guys?
42.
Good. Whoever said that. Does 3 go evenly into 84? I see people are typing in the chat. 84 divided by 3. Does that go evenly? It should. What do we get? What do we get when we do that?
84.
So 84 divided by 3 is 20 what? 28, right? And then we got 4 times 21. 5. How about 6? Does 6 go evenly? How many 6s are in 84?
12.
12. So now my question to you folks is, let's circle the common numbers that are both in 42 and 84. Who can help do that? Who can help me? Is 1 a common number? Oops. Is 1 common?
Yes.
Okay. What else is common? Help me out.
21.
1, 21. Any other common numbers that you see?
8. No.
Got to be in both. Is 42 a common number in both?
42.
Any others?
6.
No.
6. What else, folks? Any others, or that's
3.
it? 3.
3.
Yeah, good. Any others?
No.
Okay, so
2.
what is the greatest common factor? The GCF of 42 and 84 is what number?
Is it 1?
The greatest,
42.
42. So we should have picked choice C on our paper. You all see that. That's how you do that. So my screenshot person, I forgot who that was. Who's taking the pictures?
Me.
Me, Haley. Can you put this up for us and call this number 1, please? Remember, GCF, you're listing, okay? LCM, you're skip counting. Yeah? Haley, give me a thumbs up when you took it so we can move on, dear. You're good? No, okay. All right, so just take that in because this is what today's independent and exit ticket will look like. I'm just gonna wait for Haley to give the okay. You good, Haley, with the picture? Okay. Problem number 2, we're gonna find the least common multiple now. So who would like to tackle this one? Who's gonna tell me the annotate? What do we annotate? Easy. Somebody. It says, what is the
The
least
least common multiple
good of what?
of 4 and 10.
Good. So the least common multiple, this one's pretty straightforward, right? Of 4 and 10. What do we have to figure out? What is the restate?
We have to figure out the LCM
Of
4 and 8.
good. I know it's a little redundant, right? Find the
Yeah.
L. Yeah, I know it is redundant, but it's called, that's what good readers do, right? They reread and things like that. Okay. What model are we using? Are we skip counting? Are we finding factors? Like, what are we doing?
We're finding the
do we-
least common multiple of 4 and 8. I mean, and 10. Sorry.
And how do we do that? Do we list the factors or do we skip count?
We skipped out
Good. All right, let's skip count. Let's find the multiples of 4. Who would like to start me off? Give me multiples of 4. Ready? Let's start.
1.
Okay, I want to write multiples. Multiples. We're going to skip count now. Like 2, 4, 6, 8.
Oh,
So 4. 4 times 1, 4. 4 times 2,
8,
4 times 3.
12,
Good. 4 times 4.
16,
Good. 4 times 5.
20,
And 4 times
24.
Good. Great. Okay. Now we're going.
24.
Good. Excellent. We're going to keep on, we could keep on going, but for argument's sake, for this question, we don't have to keep on going. We're now going to do the multiples of the other number was 10, Haley said. So we're going to write multiples of 10. Ready? Count with me, guys. 10.
20, 30, 40, 50.
Okay. Damn. Who thinks they can tell me what do they share in common? What number do both 4 and 10 have in
20.
common? Huh?
20.
Somebody said it. Do you guys agree with her? She said 20. Yes or no?
Yes.
Okay, so I'm just going to write up here and then my screenshot person LCM is 20. Easy, right? Remember, GCF, you list the factors. LCM, you're doing the skip counting, okay? 2, 4, 6, 8. Who do we appreciate? LCM. Got it? All right, Haley's going to let us know when she has number 2. If you understand what we're doing, can you please type yes in the chat, please? I need you to type yes in the chat if you understand this question. This is great, filling me up. Haley, let me know when you're ready to move on. Okay, let's do number 3. Oh, I love this question. This question is about a bus. Some of you may take buses or subways to get to school, or some of you maybe get driven. So this question says, I'll make it a little larger. It says 2 bus services, A and B, arrive at a station. Service A arrives at the station every 15 minutes for bus A, and bus B arrives every 20 minutes. They say that the first bus starts at 8 o'clock in the morning. When will they both be together? So now we're going to put together LCM and GCF into a real world example, right? Because there could be different bus stops near the school that come at the same time, and you want to know when will they both be together at the same time again. So which makes sense? Think about what we just did. Are we going to do GCF where we list the factors because we're dealing with time? Or Are we going to do the LCM where we have to do the skip counting to figure out when will I see both of them at the same spot together? Which makes the most sense?
The last one,
Which is what?
least common multiple.
Yes, that's what I'm talking about. So to find the LCM, we have to do what?
Find the LCM and skip count.
Great. So let's find the multiples of 15. So we got 15 times 1 is how much, folks?
15.
15 times 2, double it.
30,
Good. And then add another 15.
another 45,
Good. And one more.
45,
60.
Good. Now we're going to do the LCM of,
60,
good. Let's do the LCM of 20. Ready? 20. These are easy.
20, 40,
40,
60, 80.
60,
So we're going to do 4. Okay. Now,
80,
clearly,
100.
okay. So clearly, what would the LCM be? Which number do they share in common, guys? You could type in the chat.
60. Sorry.
60. Everyone see that? That's pretty straightforward, right?
Yeah.
But my question is, if we started at 8 o'clock and we know that there are 60 minutes in an hour, this is a little tricky now. You have to go one more step. So we know that, let's write this down first. The LCM of 15 and 20 is equal to 60. But when we deal with time, we're not going to say they're going to be together in 60. Does that make sense? Does that make sense? No, when you read a schedule for a bus, right? So we have to remember that there are 60 minutes in an hour. If we start at 8 o'clock, 1 hour later is what time? If it's 8 o'clock now and in 1 hour when you leave, what time will it be? Nobody knows?
9,
9. We start, it starts at 8 a.m. and then they are together at 9 a.m. because there are 60 minutes in an hour. Does that make sense? Anyone have any
60
questions on
minutes
that?
is an hour, so that's why it says 60 minutes.
Correct. Thank you, Haley. Good clarification. There's problem 3, folks. You guys can type your responses in the chat because I'm seeing that. Yes, Daniel. Go ahead, Daniel. Wait, what do you mean no? Jackson, you said no. What do you mean no? I don't know what you mean by that. Oh, no questions. Okay. Next time, just put no questions because I thought maybe you didn't understand the question. So I want to make sure you're all right. Thank you, dear. Perfect. Got it. Okay, let's move on to problem 4. All right, who's reading this one and doing it?
Me.
Okay, go ahead.
Carlos is arranging books on the shelf. He has 24 novels and 16 autobiographies. Each shelf will have the same number of novels and autobiographies in. Carlo must place all the books on the shelves. What are the possible number of shelves Carlo must have? Show all what you receive full credit.
Keyword is same.
So
We're
we
gonna
have to
find the
find the
LCM.
least. Or no, we
LCM or
have to find
GCF? Think about it.
the GCM.
The who? The GCF or the LCM, dear? What did you say? I couldn't hear
The
you.
GCF.
Okay, good. How do we find the GCF again? Refresh our memory.
We gotta find we gotta skip count.
We skip count or list the factors? Think about
List the factors, sorry.
It's okay. So give me the factors of 24. 1 times,
It's 24.
2 times,
24. 2 times 12
how about 3?
times
How many 3s are in 24?
8.
Good. And 4?
8,
Good. How many 4s are in make up 24?
Um,
0,
Well, not 0. 4 times 0 would be 0 though. We want to know 4 times what is 24? That's what it's asking me to find a factor. How many 4s are in 24? Is it 5 or 6, guys?
it's 5.
Really? What's 4 times 5?
6.
There you go. All right, let's do the same thing for autobiographies. So we start with 1. We know this 1 times itself is itself. How about 2? 2 times what? How many 2s are in 16?
8.
8,
And 4 times?
4,
Okay, so clearly
4.
here, good. Who can tell me what do they have in common? Don't give me the answer. What do they share? Let's start there. Let's use orange.
they share,
Let's
they
see.
share 8,
They share a 1 and an 8. Okay. What else do they share?
2,
Okay. What else?
and 4.
Any other numbers? Or
Four.
good. Now, do
That's,
they both have a 6 though?
oh yeah, they do.
Okay. So now that we know, because we have to do a few things here. So now we know, Marley, get ready. You're on deck. GCF of, what is it? 24 and 16 is what? What's the greatest number?
It's 8.
Good, 8. Now, we have to go back to the question. It says, if Carlos can place all the books on the shelves, what are the possible number of shelves Carlos can have? Well, we're going to do it for the novels. How many novels, right? This is for the novels. And then we're going to figure out how many autobiographies. So if the GCF is 8 novels, how many rows does he need? If he puts 8 per row, and you need to get to 24, look at the factor. 8 times what?
2.
8 times 2 or 8 times 3?
3.
That's 3.
Good. So 3 rows of novels. That's how we do that one. Everyone see how we got that?
Yes.
Okay. Now we're going to do it on the other side. We're going to do autobiographies. So now the question is, if we know that the GCF is 8, folks, how many rows of autobiographies do we need to get to 16? 8 times, look what you wrote. 8 times what? What's its partner?
2.
There you go. 2 rows of, oops, I don't think you guys can see that, of autobiographies. Does that make sense?
Yeah.
Anyone have any questions on that problem? If you understand that, type YES now in the chat for me. If you understand this question. If not, tell me I don't understand. There is problem 4. Okay, so I got 4 yeses, 5 yeses. I need a few more. 6, 7, 8. Okay, perfect. I got some private ones. There you go, Haley. Let me know when you have that one. We're just going to wait on you, Haley. Whenever you're ready, just give us the thumbs up. I'm done. Move on. Whatever you want to write. So real quick, as Haley does that, who can tell me how do we find the GCF? Do we do factors or we do skip count? Somebody come off mute. GCF, is it factors or skip
It's
count?
factors.
Good. LCM is what?
Is
Skip out.
Great. All right, let's do this problem. Let's try number 5. Jason Sanchez, let's hear, actually, sorry, Marley. Marley Martin, you're up. Number 5, ma'am. Please read it right in front of you, or if you have it in front of your screen. I have it nice and big for you. It says, Alicia.
Alicia is putting cheese cubes and crackers into a small plate. She has 24 cubes of cheese and crackers. Cheese and 40 crackers. She wants both cheese and crackers on each plate, and each plate have the same number of cheese and same number of cheese, the same number of crackers. What is the greatest number of plates she can make using all cheese and crackers?
All right, Marley, so you're going to start us off. When you see the word greatest, are we finding the greatest common factor or the LCM?
Greatest common factor.
Good. And how do we find that? Do we list the multiples? Do we skip count or list factors?
List the factors.
Great. Help me out. We need to know that we know how to do it. So 1 times what? is 24?
24.
Good. 2 times what? 2 times what is 24?
12.
Good. 3 times what? Anybody?
8,
Good. And 4 times what, guys?
6,
Okay, let's do 40, okay? So I'm gonna use red now. We got 1 times 40, which we know. What's 2 times what? You got
20.
Good. Excellent. How about 4? That's easy. 4 times what is 40?
10.
Good. And 5 times what is 40?
80.
All right. All right, Marley, what numbers do they have in common? Look at it. Do they share ones?
Yes, they share 2s.
They share ones. They share ones.
8.
Wait. Okay, so 2, you said 8. What other numbers do they share?
4.
You guys-
8.
Okay, 8, 4. Any others?
No.
Okay, so now what is the GCF of 24 and 40? That's the first part. Got to find the
Eight.
GCF. Huh?
8.
Okay, but are we done yet? Or we got to go one more step?
You gotta go one more step.
Is 8. So now we know that there are 24 cheese cubes altogether, but we know that the GCF, the greatest number, is 8. So how many plates? Each plate has 8. I need to get to 24. So how many plates of cheese do I need if each plate has 8 pieces? Look at your factors that you just did.
Is it 4? No, 3.
Right, because 8 times 3 is what? 24, right? Now the same thing here. Crackers, it has 40 altogether. Each plate holds 8 crackers. I need to get to 40. How many plates of crackers do I need to get to 40? If each one holds 8.
5 plates.
Good. You see, you use the work. There's nothing you have to think about. Everything is there.
You gotta use your calculator too.
Yeah. So the greatest number of plates they can make is, what's the GCF? That's what that means.
5. Or no, 8.
8.
I thought we were doing it.
It's okay. I could see why you would think 5, right? That does make sense though. Okay, there's number 5.
Let me screenshot.
Okay, you ready, Haley? I'm gonna want to hear from, okay. I want to hear from Jackson. Jackson, can you read? I want you to read this question, number 6 for us. It says Yoleni, and you're gonna try it.
Can you hear me?
Slightly. Is there a way you turn up your volume maybe, please? Get ready, Noah, you're next. Okay, go ahead, Jackson, try again.
Yeah,
Yoleni?
and Yeleni wants to make egg biscuits to sell a fundraiser. Eggs come in packs of 12 and biscuits come in a pack of 8. What is the least number of packs of eggs and biscuits?
We gotta find the least. The LCM.
Do you agree with her, Jackson? She said the LCM, Haley,
Yes.
right? Because the word least. Okay, and how do we do that? We skip count or
We
write
skip count.
factors? Good.
We skip.
All right, so let's do the multiples of 12, starting with 12. We got 12, then what? 12 times 2 is what?
24
Good. 12 times 3
is 36.
and 12 times 4.
Is 48.
Good. Let's do multiples of 8. 8 times 1,
Is 8.
8 times 2,
Is 16.
8 times 3, folks,
24.
and 8 times 4.
32.
Okay. What number do they have in common? Type in the chat.
Is that 24?
Type in the
Yeah,
chat.
24.
Good. You say it's 24. I want to see what you guys type in the chat. So some of you folks say it's 24. Let's see if anyone disagrees there. If you think the number they share is 24, I got Jackson, Yankel, Haley, Jason. They said 24. And then I have a few people that said 24 to me privately. Okay, so the LCM is 24, but are we done? Are we done with the question?
No.
No. So the LCM of 12 and 8 is 24. So now we're going to go back to the question. It says, what is the least number of eggs and biscuits? So again, if we know that the LCM is 8, that is 24. And we know that there's 12 eggs in a dozen, right? That's a pack. A dozen means 12. How many egg packets do I need to buy? If there are 12 eggs in a dozen, how many dozens do I need?
12.
You need 20.
So look, if we're at 24, how many times did I write 12 to get to 24? 1, 12 times 1, 12 times
2.
So we need 2 packs or 2 dozens, right? 2 packs of eggs to make 24. Does that make sense? If each one has 12?
Yes.
Okay. And now we want to know if there's 8 biscuits in a pack, I want to get to 24. How many packs of biscuits do I need? Look at what you did. Count how many.
3.
Good. Use your work, right? 3 packs of biscuits. Does everyone understand that? 'Cause you're
Yes.
going to have to do this in a few moments. Okay. So the least common multiple or packs of eggs and biscuits that you Lenny can buy to have an equal number is, what is the LCM equal to?
24.
There you go. You got to read, right? Because you can get the LCM correct, but then you have to do another step. Does that make sense for you all? All right. Yes, I see Jason. Javon is shaking his head. He's like, yes, I got it. All right. Haley, are we ready to move on? Let me see. She wrote in the chat. Oh, yes, yes, yes. Okay. Yes, a dozen equals 12. That's correct, Miss Haley. Perfect. Thank you. Daniel, how are we doing? Thumbs up, thumbs down? Okay. Haley, can we move on? Okay. All right. Let's try this one. I think I assigned somebody for this problem, right? It says on Saturday, a Major League Baseball team gave away baseball cards for each person entering the stadium. One group received 28 and the other had 68. What is the greatest possible number? Easy. When you see the word greatest, what do you find, guys?
GCM.
GCM or GCF?
I mean GCF, sorry.
So we got 28, 60F, we got greatest. So what do we have to find?
The greatest common factor
Of what 2 numbers?
of 28 and 68.
Great. And what are we finding? LCM or GCF?
GCF.
And how do we do
List
that?
factors.
Good. All right, so let's do it. Let's do 28. 28. We have 1 times 28. We
As
have
28.
2 times what?
14.
What else? 3, 4, what? What goes in?
3
How about
times.
4? Does 4 go in evenly? Yes.
Yeah.
4 times what?
7.
Okay. Let's now go do 68. 68 is a little tricky, but I'm pretty sure you guys can do it. 68. We got 1 times 68.
Is 68.
What's half of 68? You got $68. You give me half. How much do we each get?
30. Wait. Like
Yeah, you got it.
30.
30.
34.
Good, 34. Thank you. Does 4 go evenly into 68? Can I divide 68 by 4 and get an even number?
Yes.
Yeah,
4
what is
times
that?
17.
Good. How about 5, 6, 7, 8,
Yeah.
9,
9.
Yeah. 9, 10, 11, 12? I think we got them all right.
Yeah.
So let's look at it. What is the greatest common number that they share? Do they share a 1, right?
Yeah, they share 1. They share 2.
1, 2. What other numbers? They share 4, right?
4. Yeah.
Any others?
Share. No, I don't think so.
Oh. So this question says, what is the possible greatest number of baseball cards that each person could receive? So what should we write here? What would the LCM or the GCF be?
The GCM would be 4.
The greatest number of baseball cards that each person could receive is 4. Does everyone see that?
Yes.
So please screenshot that. Let me know once you have that. Okay, so now what we're gonna do is I am going to show you, oops, updated. Haley was kind enough to put what we reviewed. I am going to tell you that you have an independent practice and an exit ticket to do. Recap real quick. How do we find the GCF? What do we do?
Factors.
And how do we find the LCM, the least common multiple? What do we do?
Wait. Multiples.
Multiples by what kind of counting? You're right. What kind of counting?
Skip counting.
Great. So you have your independent practice, your exit ticket. When you finish that, you also have iReady to complete. You have 150 minutes due on Thursday at 3. Are there any questions on what's expected of you?